So, what's up mga kache? It's Kuya Dale here and I'm back with another chemical engineering thermodynamics lesson, and thank you for the support that I have received in my last video, which is the entropy, turbine, and um, refrigeration. So, thank you for sa lahat ng mga nag-share, at also I received a just one day I have uh, the subscribers went up by 14, so thank you for that. So let's not delay with our progress. So now I will be teaching you about the Otto and Diesel engine. So how do you solve the problems that are regarding those engines? Okay, so let's dive right into it. Okay, so shout out kay Sir Lowen for teaching me how to solve these problems. He is my teacher in Quantum Review Center. Okay, so he has taught us how to solve these problems, and truth be told, I don't know how to solve these problems back in college, but now I know how to solve these problems. Okay, so first we have a Otto cycle. So an ideal Otto cycle has a compression ratio of 10. So we have a compression ratio of 10. So let's note we have R is equal to 10. And then we have our pressure at 100 kilopascals, and then at 25 degrees Celsius. Undergoes isentropic compression, and 1,000 kilojoules per kilogram of heat was transferred to air at constant volume. Okay, so assume air behaves like an ideal gas and its properties remain constant with Cp is equal to 1.005 kilojoules per kilogram per Kelvin, and gamma okay, gamma is 1.4. This is standard for air. Okay, so let's calculate the following. So let's calculate the thermal efficiency, and then we have the mean effective pressure. Okay, so right off the bat we can immediately solve for the thermal efficiency. So there is a shortcut to that. That's it's equal to 1 over 1 minus 1 over the R, and then it's gamma minus 1. Okay, so the eta 1 over we have 10, diba, of our R, and then 1.4 minus 1, because we have gamma of 1.4 minus 1, 0.4 na lang ang natira. And then if you calculate that, I will get a 0.60, the 30 answer. Okay, so mean effective pressure is a lot harder to get. So let's draw it here. So an Otto cycle, Otto engine looks like this. You have to draw the PV diagram and PS diagram of it. Okay, so that's not that's really important for you to familiarize these diagrams. Okay, for PV diagram, for an Otto cycle, we have this. Okay, so yan. And then for TS, yan. It's just like a yan. So as you can see, it is in the mirror image of each other. So if one way to memorize that is Otto, diba? Otto. So as you can see, Otto. So meaning they are this mirror images of one another. So shout out to Sir Lowen for teaching that also. Okay, so that's how you memorize this. And then for the steps, okay, for the steps you have to number the steps. Okay, so let's start with PV. So 1, 2, 3, and 4. And also for the PS, it's also the same, but it starts right here: 1, 2, 3, and 4. For the PS diagram, actually, if you in the heat enters here, and then heat exits here. Okay, so Q23, and that is really important later on. So how do we solve this? So for easier solving, I recommend what also has been taught to me, to list all the states, so the properties of the states, like the uh, P, pressure, the volume, and the temperature. Okay, so we are given here TPA, diba? And then we have states 1, 2, 3, and 4. Okay, so next we have a volume here, volume, and then P in Kelvin. I propose to you that the units that we will be using is cubic meters per kilogram. Okay, so as you can see, there are hints that we will be using kilogram, diba? So it's much easier to use the per kilogram basis right here. So let's list all that we know, diba? At state 1, we have the pressure of 100 kPa, diba? 100. It's 100 right here. And then for T, we have 25 degrees Celsius. So let's convert that to Kelvin already. And we have 298 Kelvin. So to get V, let's just use the ideal gas formula. So it's just RT over P. And what R we use here? So because we are given the kilogram, it's also wise to use the kilogram per kilogram basis, and also the energy must be in energy units must be in kilojoules also. Okay, for us not to be confused later on, and for easy solving. So the R that we will be using here is 0.2871 kilojoules per kilogram per K. Okay, so that's the value of R that we will be using, and then we multiply that by 298 temperature and divide that by the uh, pressure, and then you can get your V1 equal to 0.856 cubic meters per kilogram. So let's put lines here. So this indicates that the values that are in underlined are obtained and not given. Okay. Next, to get V2, or any other volumes here or properties here. So as you can see, to make our lives easier, diba? One, as you can see, this is an isochoric process, 4 to 1. So meaning isochoric means equal in volume. So V4 is equal to V1 actually, diba? Because you can see it's just a straight line. So it has no change in volume. And then to get V4, to get V2 and also V3 actually, because V3 and V2 are equal, diba? Remember that your R, which is equal to 10, the compression ratio, which is equal to 10, it is equal to the V min, the V max over V min. Okay, so V max here is any, like V1 or V2, V1 or V4, but let's just name that V1. And then for V min is V2 or V3. Let's just put V2 here. So to get V2, it's just divide V1 by 10. Diba? So dividing V1 by 10, you will get a 0.0856. Same unit. So this is solved. Okay, that's it. So now we'll go to our states, diba? So first, we'll go from 1 to 2, diba? From 1 to 2, this step and this step also. As you can see, it is adiabatic and polytropic. So adiabatic here, di ba? Zero ang entropy niya. So adiabatic and polytropic. So to solve that, use equations 10, 70 to 72 in your Paris. That's in the 8th ed. Okay? So to get the you can there are a lot of equations there that you can use. Okay? So for me, can use this P2. Yan. So to get P2, it's just P1, B1, B2, yan. So just transpose it, and then remember V1 and V2 is equal to 10, di ba? So it makes our life easier. So P1 is 100, di ba? And then 10, and then gamma, we have gamma which is 1.4. Kanina, di ba? And then you get the product. So you have 2.512 kPa. So let's list that down here. 2512. And then for T3, it's actually the same. So T2 actually T2 B1 B2, but it is 1 gamma minus 1. So let's solve for T2. We have 10 here, 10.4 na lang, di ba? 1.1 minus 1.4 minus 1 is 0.4, and then you can get 748.5 Kelvin. So let's list that here. Okay, so let's go to the next step, which is 2, 3. Diba? 2 to 3. So 2 to 3. So what this is this is an isochoric step, diba? Isochoric step because the volume does not change. So isochoric step. Also 4 to 1 is isochoric step, and step 3 to 4 is also adiabatic and polytropic. Okay. So how do we get the temperature here and the pressure? So remember, we are given the 1,000 kilojoules per kilogram, diba? So it says that it goes isentropic compression, and then heat was transferred to air at a constant volume. So meaning, diba, this is the constant volume, diba? And then isentropic process, isentropic compression, and then it was transferred during constant volume, di ba? Constant volume, at constant volume siya. So meaning it was here. So meaning that Q in is equal to 2 to 3, di ba? So that's Q 2 to 3 because it was added at constant volume. So we have 1,000 kilojoules per kilogram here, right? And then actually the Q here, the Q23 is equal to the delta U. Diba? Isochoric step, meaning let's go back to our first law of thermodynamics. Yan, diba? Delta U is equal to Q plus W. So isochoric step meaning there is no work because the volume does not change, diba? That's Px dV. So isochoric man, so 0. So meaning W is 0. What we are left with is with Q, diba? So Q23 is equal to Cv dt, which is the delta U, the formula for delta U. So we have a 2.5 R here. Cv is equal to 2.5 R for diatomic molecules such as air. Okay, so let's 2 at P3 minus P2. Okay, so we have a 1000 here, and then 2.5 R is equal to 2871. And then P3 we don't know yet, that's what we are finding, 748.5. Okay, so P3 is equal to 2142 Kelvin. Okay, so let's list that here, 2142. Okay, so next is we have to get the P3, diba? P3. So P3, because this is isoporic step, so the volume is constant, but other other properties are not. Okay, so P3 can get P3 is equal to P2, P3, P2. Okay, so P2 is equal to 251 2512 times 2142 over 748.5. Okay, so we can get 7,189 kilopascals. Okay, let's list that here. 7189. Okay, and now for the final step. So for final step, it's just 3 to 4, diba? As you can see, it is also adiabatic and polytropic. So use the same equations. So we have P4, P3, we have V3, V4, diba? And then this is raised to gamma. And then as you can see, V3, V4, diba? V3, V4 is actually the reciprocal of 10. So it's V3, V4. So 1 over 10. If you don't believe me, just check it for yourself. P3 is equal to 7189, diba? 7189, then 1 over 10, then raised to 1.4. So you can get 286.2 APA. And then to get P4, so it's just the same thing, 2142, diba? Then 1 over 10, just raise that to 2.4. Okay, and then you can get 853. Yeah, 853 Kelvin. So let's list all that we have got here. So 286.2, and then we have 853 Kelvin here. So next, we have to get the mean effective pressure, and the formula for the mean effective pressure. So mean effective pressure is equal to W net as the absolute value of the net work, and then V max minus V min. Okay, so to get the work net, so we have to solve for the individual work now. So actually, for the work, diba? So for step 1 to 2, the work there, so we have to solve for it. So what formula of work are we using, diba? So let's go back to the first law of thermodynamics. So as you can see, 1 to 2, diba? 1 to 2, 1 to 2 here, 1 to 2 here. So this implies an isentropic step. So what happens in an isentropic step is equal to 0, diba? ds is equal to 0, and we know that ds is equal to dq over t. So if this is 0, dq is also 0. So meaning 0 ang ating q. Okay? So W2, W12 is equal to CV delta T, diba? Is equal to the internal energy. So CV delta T, so we have 2.5 R and then T2 minus T1. Diba? So they solve for the use that 0.2871. Let's fix this, and then 748.5 minus 298. Okay, so you can get 12 is equal to 323.35 kilojoules per kilogram. So that's the work 1 to 2. Next is a work 2 to 3. So as I said earlier, that the work 2 to 3 here is 0, diba? Because it is an isoporic step. So let's go for, and also 4 to 1 is also as an isoporic step, so meaning work is equal to 0. So the only thing left now is the work 3 to 4. Work 3 to 4 is still equal to CV dt. Okay, so for the same reason that I have derived this equation for you earlier. So 2.5 R, so T4 minus T3. So 3.4 is equal to 2.5.2871, and then 853 minus 2,142. So 3.4 is equal to negative 925.18 kilojoules per kilogram. So let's input that in our MEP. So MEP is equal to the absolute value of our network, 323.35 over the Vmax. Vmax, we know that earlier we got that as 0.856, diba? Minus the minimum volume of 0.0856. So as we get the answer there, solve it in your calculator, you have 781.2 kilopascal. Okay, so this is letter B in our answer. Okay, so that is for our Otto cycle. So now let's go for our diesel engine. So diesel engine, so we have P, and then we have our P, and then compression ratio R is equal to 15, diba? And we have the maximum temperature of 2000 degrees Celsius, and we have to determine the following here. We have to determine the network, the mean effective pressure, and then for the cut-off ratio. Okay, so let's solve this. For diesel engine, so diesel engines are used for bigger trucks. For example, trucks L300, yes, L300. I think Hilux uses diesel engine. Anything basta mga dagko nga sakyanan, diesel na siya, compared to your auto engine, which is used for automobiles. Okay, so for the PV diagram of diesel engine, how I memorize this is just, it looks like a macaroni salad yung pasta. So looks like a macaroni salad, elbow pasta. So that's how the diesel engine on PV diagram. And then the TS is just actually the same as the Otto. So, yan. Yan. So, let's number 1, 2, 2, 3, 4. 1, 2, 3, and 4. So, as the previous slide that I have shown you, let's also write list the states, diba? So states 1, 2, 3, 4, and then let's put PPA here, and also the assumption of the units is also in meter cube per kilogram. And then for the temperature is just Kelvin. Okay, so we have 90 kPa here, and then we have 293 Kelvin there. So let's just put these value underlines here. So we have the maximum temperature, diba? Maximum temperature, where will we put that? So maximum temperature is actually here at state 3, diba? The temperature is highest here, so we have 2000 degrees Celsius here. So let's convert that to Kelvin. So we have 2273, and then we don't know these values yet. So we have our compression ratio, which is the 15, diba? So let's solve for V1 first. So V1, just like earlier, so V1, just we know the value of R. We will not write that here. It's just 0.2871, and then 293, and then 90, diba? So, and then you can get 9347 meters cube per kilogram. So let's just put that here for 7. So notice that 4 and 1 has the same volume. So let's put that there. And then we have to solve for our V1 and V2 and V3. But V2, actually V2, so remember that our compression ratio is Vmax over Vmin, diba? So what are these values? So in the state, so we have 15 here, and then Vmax, diba? So Vmax, this is the maximum volume, and this is the minimum volume. So this is V1 over V2. So getting V2, just divide the V1. So we can get V2 equal to 0.0623. Just divide the V1 by 15, and then you can get this value. So 0.0623. So let's get to our steps. So 1 to 2. So 1 to 2 is always adiabatic and polytropic. Okay? So same earlier, we have 90, diba? 90, and then we have our compression ratio raised to 1.4. We have 3988 kPa, and then T2, which is equal to 293, diba? 293 raised to 0.4, okay? 0.4, and then you can get 866 Kelvin. So let's list that here. 3988, and then we have 866, and then we go to 23. What can you notice? So instead at the Otto, diba, isochoric step nito, so now we have an isobaric step. Step, meaning we have the same pressure at state 1 and state 3, diba? So state 3, same. Okay, we have a 3988 also kPa. So now we will find the volume. Now we're finding the volume. So how do we find the volume? So let's use this V3 is equal over T3 V2, V2. So V3 is actually V2, T3, T2. So let's substitute uh, 0.0623 times up to 2000, 2273 over 866. Okay, so V3 is equal to uh, 0.1636 cubic meters per kilogram. So let's write that here, 1636. Okay, so now we will get to step 3 to 4 now, which is still adiabatic and polytropic. Adiabatic and polytropic. So what I have taught you earlier to get the volume pressure faster, so 3988 by just the reciprocal of your R, and then 1.4, and then you can get 347.6 kPa, and also 4 T4. T4 is equal to 2273, still 1 over 15 dion 0.4, and then you can get a 1132 Kelvin. So let's list that here. So that 6 and then 1132. So let's get the work. So let's use the another sheet. So work 1 to 2 is still equal to CVDT. For the same reason I have derived for you earlier, 2.5 R, and then T2 minus T1, 1, 2. We have 2.5. Still use the value of R that we are using in this calculation. We have 866 minus 293. You can get 411.27 kilojoules per kilogram. Okay, so now let's go to work 2-3. So this is isobaric, diba? So this is isobaric. So meaning we have to use this. Yan. So we have 3988, then V2, V3 minus V2, so 0.1636 minus 0.0623. So we have 23 is equal to negative 403.98 kilojoules per kilogram. You have to units. And then let's go for 3-4. Where 3-4, it's just the same. CVDT. So we have 2.5 R T4 minus T3. Okay. We have 1132 minus 2273. So we have 3-4 is equal to 818.95. So get the network. So net. So let's add all of these together. 895 and then 403.98 plus 411.27. So get the network is equal to 866 kilojoules per kilogram, or negative 812 kilojoules per kilogram. Okay, so that's letter A in our number 38. So let's go for let's solve the mean effective pressure, which is actually the next that we can get here. So we have the to get the absolute value of our network, which is 812. Let's just use the unrounded off one, and then the Vmax over Vmin, Vmax minus Vmin. So we have 0.9347, diba? And then minus 0.623. Okay, so get the one using your calculator, and then you can get 930 kPa. Okay, so that's letter B in our choices. And then for the last number 40, which is the cutoff ratio, cutoff ratio RC is just equal to V3 over V2. Okay, V3 over V2, so 0.1636 over 0.60623 can get 2.63. Okay, so that's letter B in our uh, choices. Okay, so that ends our actually relatively short video for this one. So I'm still using the MRII book. So I have shown you in the last video. So if you want to solve with me, please buy that book, or actually the same. You can search for an online copy of that. So just keep on solving. Okay. So this I will end the video here. So thank you for all your support, and um, please pray that we will pass our board exam this May 11 to 13, 2021. And I hope and pray that it will be uh, pushed through, because we are tired of studying already. Okay, so that's it. Bye, anyong. God bless.